I'm not really going to teach you anything. And it's one of those things about the differences between education and training. So I'm hoping that it might fall more into the education category. But my main role will be to open a door for you. So I'm going to be talking about impossible documentation, and I do that simply by running through an example. And I'll set the scene first of all. And obviously we're living in, somebody was just talking about the millennials, we're living in the 21st century, right? And if we look at the tools and the methods we used to create documentation last century, we can find tools such as Microsoft Word, released in 1983, FrameMaker in 86, RoboHelp in 1992, and now I'm a bit nervous because I know that Adobe is one of the sponsors of the conference, but I'm not dissing, it's okay. XMetal was released in 1999, Arbitex in 1986. And when you look back at some of those things, that looks a little bit scary because that was truly last century and that seems a long time ago. And many of us will be using some of those tools. And even if we're using like the more recent tools, things like Confluence was 2004, Flare 2005, Oxygen 2003, they just scooted into this century. So if we look at other things from the same era, it gets a bit scary. So the Swatch. Now I realise that a lot of you are young people. Do you ever remember the Swatch? The Swatch was a trend in 83. The Sony Betamax camcorder was from the same era. The first IBM laptop computer. And by now, you probably can't see out there, but there's 7 laptops out there. It's amazing. First SMS message. The Melissa virus, that was another good one. iTunes Store was opened in 2003. And MySpace and Facebook were founded in 2004, 2005. And YouTube was founded in 2005 as well. So that gives us some sense of where we're sitting in the space-time continuum. So if you think about that, you're saying, God, some of the tools I'm using are as old as MySpace. And I realize that not all of you come from Poland, but I thought I'd give it some context and think that means some of our tools are older than the Third Republic. So it doesn't make much sense to me, but I hope it does to you. Now, the door I'm about to open is to something that I'm interested outside technical communication, which is flying aeroplanes. So I'm going to talk about general aviation, which might not seem to relate much to what we're talking about here. So general aviation is just small light aircraft. So light aircraft, if you hire or learn to fly in a light aircraft, one of the purposes of a light aircraft is to take you from one place to another place relatively quickly. And that means you need to navigate to get there. So you need to find your way there. And it's a little bit complicated because there's wind and there's cloud and there's magnetic variation and compasses and things like that. And so it's actually quite complex. So in the last century, so in the same era of Microsoft Word, the method of navigating involved charts. So you'd obtain charts and they would give you information about airspace boundaries and radio frequencies and so on, as well as geographical features. And then you'd also use computers. But remember, this is last century and computers don't mean what they mean now. So a computer actually looks something like that. And where somebody there is working out what their drift angle will be based on if they're flying in this direction, the wind's coming from this direction at this speed, and they're traveling at this speed, how many degrees will they be drifting off course by virtue of the wind. And so there's some calculations that you need to do with regard to fuel, etc. too, and were also done with the computer. So this looks very archaic. I'm hoping it's looking archaic to you because it feels like that. Then there's other things such as plotters and rulers and protractors and weather charts. This is actually a current weather chart which gives you different freezing points and wind speed and direction at different altitudes. So if you're traveling, this is obviously, or maybe not obviously, this is a map of Australia there. And so when you're plotting your path, you choose, well, I'm going to be travelling roughly there to there at this altitude, therefore I'll try to calculate what the winds might be. So hopefully this is complicated. You've got a new appreciation of what's involved. It's not just hop in a plane and set the GPS. Weather forecasts in the last century were also given in code because they go on teletyping machines from one point to another. And so it's very complicated to try to decipher what those mean. And then we get to another issue which is not directly related to navigation, but it's the weight and balance of the aeroplane. So you put fuel and passengers into a plane. Over time, the amount of fuel decreases, and that changes the balance of the aeroplane. And then depending upon whether the runway that you're landing on is wet, and how heavy your plane is, you might need to calculate runway distances. So how long a length of runway you'll need to be able to land. And that's done with these complicated charts as well. So at this stage, this is probably putting you off ever learning to fly. And on top of that, if you're traveling to another place, then you need to know what directions the runway's in and how you join the circuit and what fuel is provided and so on. And there are things called airport plates that allow you to identify that too. So as you can imagine, when you go to fly from A to B, in amongst your weight and balance calculations will be the weight of the paperwork you have to take. So there's a big flight bag you take with maps and charts and plates and computers and protractors and compasses and so on. So it is quite complicated. But then something happened. Then GPS became available. So GPS is actually from last century, but it was military for a while, and then it became available to general aviation. And then somebody invented LCD screens so that you wouldn't need a cathode ray tube or something big and bulky that used a lot of power. And then that led to, so those two technological advances led to innovation. And that's, if you're looking for lessons out of this talk, that might be one of them. That usually some invention leads to some innovations. And so various avionics companies took advantage of those technological advances to produce innovative things. And one of them was something called the glass cockpit. And so this is an example in a general aviation aeroplane. These round gauges here are now called steam gauges because they're so old. And so this is now a little computer that is embedded in the cockpit. And then that contains information that used to have been displayed on steam gauges. And the sort of information was based on the inputs that are available to it. So if we think about, you're flying in an aeroplane, I've just discussed briefly the sorts of things that you need to know. What sort of inputs might you expect? So at the back of that device, what's being plugged into it? So think maybe thermometers, yep, that would be one because of that, the freezing point and the engine operates at different temperatures differently. Maybe a compass, airspeed indicator, things like that. And that's true. There's airspeed, altitude, your compass, there's a thing called the directional gyro, then engine information, how hot the engine is, how fast it's running, etc. And then also that has a GPS, so it's able to identify which location you are on the face of the Earth. That is in latitude and longitude, and it can calculate ground speed and so on. And then there's computations involved as well, so that's another important part. So when we saw our computer before, a poor little human had to go and do the computations, but now we've got an electronic computer that can do the computations automatically. So that was another big change. So in amongst our inputs, we can do calculations that can turn a heading, that is the direction you're flying, into a track, which is when you account for how far the wind is causing you to drift. It's the angle you're actually, or the direction you're actually passing across the surface of the Earth. Now, these glass cockpit items were revolutionary because they were low cost. And by low cost, probably around, and translate this into your own currency, it was roughly about $10,000 for one of these units, which seems a lot of money, but in aviation it was classified as low cost. But then something else happens. But if we just lock in, so we know that $10,000 is low cost. Then something else happened, so another technological change that resulted in innovation, and that was the tablet computer came out in 2010. So we're now well into our own century now, and we can see that tablet computers, or we know that tablet computers already have inside them a GPS facility. And they have 3-axis, not all, but some have 3-axis gyroscopes and accelerometers. And they obviously can do computations of various sorts. And they have connectivity. So they might have Wi-Fi or Bluetooth connectivity. And they can be networked so they can take advantage of other computers or other sources of data from somewhere else. Some of them have a compass, which curiously they call a magnometer or magnetometer, which I'm not sure why there's probably some technical difference, and a barometer, which will help with the air pressure, and obviously a camera and a touch screen and so on. So with the arrivals of tablet computers, you can probably see where this is going. So we can now find that there's a convergence. So you've got your computers and your maps and your graphs and your plates all being integrated into a piece of software that runs on the laptop or on the tablet computer. So now we've arrived. So this is the software that I'm talking about, which is called AvPlan. So it happens to be an Australian product and happens to be made in the same city that I'm based in Melbourne. So the benefits of AvPlan are probably going to be obvious, but the cost, it costs about $500 for the iPad, and again, translate into your own currency. The app costs about $100 a year, and then that might compare with, if you say, well, that's expensive compared to a chart. Well, it's not really. The charts cost $12 each, and one of those little computers that you play with is $50 as well. And then the little plotter, a ruler with a protractor on it, that's $20. So all those things add up anyway. So it turns out that it's roughly the same cost as the other pieces of equipment. You can have one of these electronic devices, and the benefits are enormous. The main one is in time. So something that might take you 2 hours might take you 10 minutes. So that's a big benefit. There's greater accuracy because you're eliminating a lot of the human error, not all of it, but a lot of it. And some other things, you saw that weather chart before, trying to calculate if you're flying at an altitude in between two of the readings that are given and you're passing 3 zones, you're just guessing numbers. So at least the AvPlan system can calculate it in some way. And then it can do impossible things. So, and this is where we will be trying to relate this back to documentation in a minute. It can see other aircraft because it's networked, and other aircraft are using the same software and using other software that's integrated. And so then all of a sudden on your tablet you can see where other aircraft are in your vicinity. And there's other things such as synthetic vision, which gives you an artificial horizon and a view of what you should be seeing on the ground. And other electronic flight information systems it's giving you. And it calculates this thing called lowest safe altitude, which is almost impossible to otherwise calculate. So it's doing those really impossible things for you. So now we'll look at documentation. I realize we've taken a long time to get to this point, so let's look at documentation. So how are the AvPlan manuals presented? So this should be of interest to us. And the answer is as a PDF. And this is incredibly frustrating. Why are they doing that as a PDF? So one suggestion is because they're living in silos. Whoever's doing the documentation lives in their own little world and likes Microsoft Word and produces PDFs, and it's all happy, and doesn't notice that the software that's being supported is this incredibly high-tech, advanced system. It actually gets a little bit worse because they are actually using Microsoft Word behind the scenes. Isn't metadata wonderful? And it's not even a modern version of Microsoft Word either. So if we just cut back a bit and say, well, how would we do it better? How would we do impossible documentation to support an impossible product? AvPlan has various inputs. So it has weather, it has air services, it has databases of its own, it has the iPad magnometer, and it has GPSs and Bluetooth, etc. So it has different inputs. So if we thought, what are the inputs that we might use for documentation, for the documentation for AvPlan? Well, let's spread it if you can't relate to AvPlan. If you're just documenting some software of some sort, what sort of inputs might you have that we haven't thought of previously that might help us provide a better experience for the end user? So it could be things, is the user seated or standing? That could be important. How long has the user been at the task? That might give an element of frustration. What task is the user performing? That could be a good input. How old is the user? That might have an impact on things. What other software does the user have on the computer and that they might be using? That could be a useful input. What device is the user reading from? Does the user prefer video or text? What language does the user prefer to use? So these could all be inputs that we could use for impossible documentation. And then we can look at what tasks can we automate. So we saw that AvPlan automated a whole lot of tasks, made it really easy to do things that were otherwise a manual labor-intensive set of tasks. So if we think of the sorts of things we might do typically, in fact, to use AvPlan, if you're preparing and then you're saying, how do I change the weight of my passengers? Then the normal task that you go through, because you only got PDF as your help system, is to forget the PDF and browse to Google, to search for a phrase of some sort, click a result that sounds good, search within that document, see if it's what you're looking for, find a matching scenario, and then do some sort of translation, because the scenario probably says something like, enter your direction such as, or enter your airport code such as such and such. And that's not my airport code, that's the example airport code. So you might need to translate a little bit, and then Alt-Tab back and forth to the application, and then if that didn't work, go back to step 2. So maybe that's some of the steps that we could automate in there. And by the way, if you start to look around, these things are happening, and probably with some of the documentation produced by people in this room, there's some of those things are already happening. And as I was preparing this talk, I needed to do something within Gmail, and the help system actually, and I referred to the help system, and they actually said, you need to sign into the admin console, but don't use tony.self5@gmail.com because that's not the administrator account. So the help system was actually customized to explain to me. I didn't have to translate that context. So let's do the impossible. So if we were going to make our help really useful, then maybe we'd have AvPlan in front of us and we'd open help on our smartphone. The smartphone knows what application we're using, and it knows what task we're involved in, and it displays a topic related to our task. And the sample data it brings in is data relevant to our own task. So it can read where we're traveling to, so it puts in our airport codes, to give us a better example, or our aircraft type, or our number of passengers. And then when it's showing screenshots, they're an exact match to my scenario, not a generic. And it could be that maybe I prefer a video topic and the system would know that from various inputs. Or maybe, because in the case of AvPlan, maybe it might play an audio help through my headphones because I'm busy in the cockpit. It might do that. Or maybe it telephones a bot for us and the bot answers, or maybe it phones a help desk. So it could do all those things. All those things seem impossible, but when we actually get down to it, they're not impossible. Technically, it would work through connectivity, and so Bluetooth is everywhere. So you just Bluetooth from the computer to the tablet, use metadata and various inputs of various sorts, such as what applications are running, etc., user preferences, and so on. And with the screenshots, it could be using some form of SVG graphics to dynamically create a specific screenshot for us. And obviously it would do computations as well. Oh, metadata, how did that get in there? Okay, so we just got a final brief example. Now I know you have these in Poland because I passed a Husqvarna shop, but this is a mower that you use to mow the lawn, and so this is also something that might not directly relate to you, but if we think about, okay, we've got a mower, we've never used a mower before, or maybe we have. How do I get it going? How do we get it started? So if we start to look at the impossible sorts of things, we can work out things that might be useful in starting the mower and things that might be known by the mower. So we won't read through all these, but things such as the mower will start differently if the engine is warm versus the engine is cold, because you might need to prime it if the engine is cold. And it might be a good idea to start it on a flat surface. So maybe the mower could know whether it's on a slope or on the flat. And maybe it could work out how high the grass is and adjust the cutting depth. Maybe it could use a little laser to do these, to work out how long the grass is. So it's quite easy to find those inputs because many of those inputs are already in a mower that you go and buy at the shop already. And if you're working with product developers and not working in a silo, you might be able to suggest how difficult is it to put a laser in a mower. It's probably easy. It's just nobody's thought of it before. And then there'd need to be some data exchange between maybe your mobile phone and the mower so that the mower information could be sent to your mobile phone in some way, maybe through Bluetooth. And so maybe on your mower you would have a little place your phone here. And so maybe you put your phone there and that would connect it with Bluetooth, or maybe using NFC, near field communication, and you plonk it there. Oh no, it's jammed. Lucky we're near the end. yeah. Well, I might describe then. So we have our mower and we've got a little panel at the front. You bring your phone over to it and you touch the phone onto the mower, and then it gives you some instructions. So the instruction could say, move the mower to a flat area, because if you start it might run down the hill. So it could say that. Oh, here you go. Or it could say, miss the mower, need some oil. Add half a cup of 10W30 or whatever the oil grade is. This is something that would normally appear in a manual. But why would you need to look at the manual? If the mower knows it's short of oil, why wouldn't it just tell you? And so this could be using, by the way, e-ink. So this could be an e-ink panel now instead of the mobile phone. See if yep, that's right. Or maybe if it was on the mobile phone, it might say, move the mower onto the lawn, because you're trying to start it on gravel, and then press start. So it could be proper task information, but it could be presented in a way that it removes steps that are not relevant due to the particular context. Or it could present things as a checklist. So, yep, oil's good, fuel's good, it's on a level surface, whoops, not on lawn, whoops, it's not quite flat, or whatever, and all the height of the grass is right. So it could actually give you almost a checklist as a way of working through this. Or it could work out, this is the first time this person's used the mower, I'll give them an introduction into how to use the mower. So it could be that as well. So you might think, well, that's a bit fanciful, but hopefully you don't, because it's actually not all that fanciful. That impossible documentation isn't actually all that impossible after all. And I can just illustrate by saying, let's just go back, don't bother going back to last century, just go back to 2005 and pretend you're buying a car in 2005. And if somebody said to you, would you like to have auto park on your car? And would you like to have lane detection and auto braking and flat tire detector and brake wear sensor and a Bluetooth connection to your phone and so on, you'd say, yeah, come on, this is not the Jetsons, because that was science fiction in 2005. But now, if we come back to 2018 for a minute, that's in Hyundais. So it's, and I could insult some other car manufacturers, but I better not. Now, I'll just wrap up by saying, what about me? Because I mentioned that Avplan is created in my town, and they're using PDFs. So what am I doing about it? And this is where I feel really guilty. So this applies to you too. So I'm not taking the blame alone. We need to look for opportunities look for opportunities to improve the way documentation is presented. It's not going to be as expensive as we think it is, and we need to try to avoid doing things the way we've always done them, and being able to build a case for arguing that, so that we can go to AVPlan and saying, you realize you're using 20th century documentation tools to support a 21st century product. We need to be able to argue things very effectively. And we need to make documentation a feature of the product, not like a cost center add-on. And probably finally, we need to find some way of enthusing engineers. So if we can enthuse engineers and get them on board and then get them to put the lasers in the mowers and things like that. So it should surely be easy to convince the AVPlan engineers to move away from PDF. So if I come back next year, I hope to be able to report to you that that has been done. And I hope from your part that when we discuss things next year, you, or maybe some of the case studies that are shown, will be forms of impossible documentation. So thank you very much.
Thank you, Tony. Okay, guys, we can allow just one question. We have one question there. I think you, yeah, it's like, yeah, I think you got it.
Hi, I'm Katarina. I'm a technical writer. And on the subject of enthusing our engineers, or in my case, devs, how do we actually get the buy-in when we have customers who are requesting specific features and we have devs who only have so much time? And we say something like context-sensitive help will help our users, and they say, well, this new feature would be the thing that would help them more. How do we help strike that balance?
That's a very good question, and one that's baffled me for quite a while. I am not good at that. I try to argue things and try to present figures, etc., but I don't have the sort of the persuasive sales type patter to be able to make a good case for that. However, I have heard a view that this is something that technical communicators should actually focus on, because in general, we're not good at this sort of thing. We're not good at selling ideas and enthusing other people. We sort of get carried away in our own world. So one of the suggestions I heard is that you should deliberately work on an elevator pitch, or a 2 or 3 minute argument for why this product or why this feature or why this approach should be taken in order to do that. So that's unfortunately the only suggestion I have. So, okay.
Okay, I'm sorry, we can't really allow more questions, but Tony is here with us, so you can approach him during the coffee break that's starting now. Thank you so much, Tony.
Thank you. Thank you very much.